we will get started. And sorry for the delay. There was some problem trying to get the display up. So can you hear me okay from the back, or do I need to use the microphone? Okay, so I'll probably use the microphone then. Hello? Is that better or? Yeah. Okay. Okay. So this week we're gonna cover something slightly different. So last week we talked about Vue, we give an overview of all these maybe 4 or 5 different directives you can use in Vue. And this week we're gonna look at something slightly different, which is the version control, and gonna use a particular software called Git. So anyone used or heard of Git before? Wow, I would expect it's a bit more. Or anyone heard of GitHub? Yeah, okay, GitHub, yeah. So GitHub is a website we're going to show later on. It's a place where you can put your software online, and the way you communicate with the website is mostly done using Git, which is the way you're communicating. And of course, you can use its web interface as well. Okay, let me see if I can get the slides going. Okay, but first we have to introduce a concept called a version control. Okay, so that's a definition. It says a system that records changes to files or even a set of files over time, and so you can record a specific versions later. Okay. So this is something you probably do all the time. For example, and you might creating a document, you name it version 0.1. And then later on, you have a new version, it's named to version 0.2, and it goes on. And you can do this for your code as well. So not just to say your Word document, you can apply the same thing to HTML, CSS, or JavaScript. Okay. So you can do this manually, as I said before, give a different version name for each file. And then when you want, you can go back to any previous versions. Say, I want to go to version 0.5 now, which will be quite easy because you have a copy there. And then the difficulty comes when you have not just one file. And for example, you're creating some apps, you maybe have 20, 30 files, they are in different directories. Okay, and then at that time, when you're doing the manual version control of each individual files, becomes much more difficult. So you're gonna have different version numbers or copies of the same image files again, or the HTML or the CSS. And so this is when the version control software comes in. And so the software, which is called version control system in general, or VCS. So it allows you to select any files you want to create, go back to any previous states, which is so long as it's saved in the system. Or you can say reverse the entire project. For example, for your coursework, you have 20 different files, everything go back to a previous state. And you can also compare changes over time. You can see, okay, what's the difference, what the changes I make between version 0.5 and 0.6, or the 2 versions in your system. And this, for example, can be quite useful to see what changes you made to break your code. So that quite happens. So everything is working fine. And today I add a new function that everything don't work anymore. But I can't get back to my previous versions, or I don't know can't quite remember what exactly I changed. So I can fix the problem. So that's the benefit. If you have the version control system, you'll be able to see exactly what the previous versions are and what change has been made between the versions. So you can know, okay, I made these 3 lines change in this JavaScript file. That's all I made today. So definitely has to be these 3 lines that cause the problem. So you can either take it out and see how that caused the problem and try to fix it. Okay, and the other things is using a version control system makes it much harder to lose your files. Okay, so I think that that's often happened to some of the students. They say, okay, just before the coursework deadline, my USB doesn't work anymore, I lost my computer, or my hard drive crashed, so you lost everything. Okay, but this should not happen again, or will not happen again if you're using a virtual control system, and especially if you're using something like GitHub to store the different versions of your code, then it will be saved on a remote server. So it's almost like you save all your files on one drive. So only until one drive completely crashes, then your files will be still there. It doesn't really matter what happens to your own computer. And so it does come with a little bit overhead, because you have, for example, to keep track of all different versions, and there's extra overhead in terms of managing these. So, and so I guess the earliest version, or the simplest one of these version control system, is local. In the sense, everything is done on your own computer. And so this could be your manual version control system, instance having a different version number for each copy of the, or each iteration of the file. And as we said, this manual version, manual approach does not really scale when you have lots of files. The file doesn't work. Okay, somehow it's missing a picture here. Okay, maybe we can, let's see, we can just keep this going without the picture. So I try to explain. So, and what this local version control system does, it keeps a copy of your first file, and then it keeps something called a patch set, which is the difference between the versions. So if you had the first version of your, say, index.html, and you made some change to it, then the software will record what's the difference between the first version and the second version. And it does not make a new copy of the file, but only the difference you made between these two files, the two versions. And they keep going on. As you make more and more changes, it will have a sequence of changes, which is recorded. Okay, another type is called a centralized version control system. So this is when you use, and we're working with more than one people. So you're creating the app, you have a team, you probably not have, you have more than one people working on it at the same time. So everyone have to contribute to the same software or app, but then you will have different versions. How do you coordinate? So not one person is breaking other person's code, or one person is working on a later, older version of the code where the code itself has already changed. So this is where the central version control systems comes in. One of the quite famous one is called the CVS, and later on called the Subversion. Oops. Oops. What happened? Let control. Run. Okay, yeah. All the links, pictures doesn't work anymore. Okay, so I might skip some of these fairly quickly. So basically, what happens is, I think I really need the picture here, which is somehow not there anymore. this one. Ah, of course. Okay, give me 1 second. I need the Wi-Fi to be up so I can show the pictures, which is currently missing. Okay, that's better. Let's rerun everything. Ah, still not. Control. Okay, that's better. Ah, that's annoying. Okay, so at least I get some of the pictures back. So I have a picture now for this so-called, we said a little bit early on about the local version control system. And so this is your local computer. This is the database, which stores all the versions you created so far. And this is your current version of your document. And the database itself would stores all these previous versions and match them for you. And you can tell it, okay, I want to go back to version 2 now, or say I want to see what changes I made between version 1 and version 2. Then all these can be done by the software itself. And so this is the next one, which is called centralized version control system. And so in terms of the version control system itself, it's not that different from the first part, the first type. So you still have a database, and it stores all the versions of the document. And the only difference now is, say, usually this is now stays on a server that people can access remotely. It's not stay on one person's computer. So only one person can access. So now person A can use computer A, can access all these different versions, and person B using computer B can also access all these versions. And this allows, say, teams working on the same project can contribute to the same code base and manage, say, conflict or changes, etc. So that's the centralized version control. Okay, and as it says, and then could be some potential downside is, for example, if this server is done, and because maybe the server is, has a disk problems, or the server is disconnected from network, then no one can access the old versions at all now. So that can be a potential quite big problem. Okay, and so this is where the distributed version control system comes in. Okay, so the examples will be the distributed version control is Git and Mercury, which is something quite similar. So in this case, in a distributed version control system, every computer has its own copy of the entire version database. So let's say this is your server, and which is a bit small, and which is exactly the same as the server we had in the previous slides, this one. But the difference here is each of these people accessing the server has its own local copy of the version database. So as a result, even this server is done, or this person is disconnected from internet entirely, it still has its different versions and will be able to work on it. And each of these is called a clone of the database. And then the challenge comes in is how do you keep all these different copies of the version database synchronized? Say the people, if they make some changes in their local version database, how do you make sure that is reflected in the server and in other people's version database as well? So that becomes the challenge. Okay, I try to make this slightly bigger. Okay, so as I mentioned before, so the Git is one of this called distributed version control systems. So each people that belongs to one they called Git repository, which is essentially a project, has its own copy of the entire versions. Okay, and then one of the main difference between Git and other version control systems is what it keeps. Okay, as I mentioned before, most other systems, it stores the changes between the versions on the server. So, for example, we have these 5 versions stored in the database, and then the server actual data stored will be version 1, and then the difference between version 1 and version 2, assume you made some changes, but version 2 itself is not stored. And similarly, it will store the difference between version 2 and 3, 3 and 4, and then 4 and 5. So then, for example, later on, if you need to get to version 4, and the server will first have to get version 1, and then apply all the changes between these versions and until it gets to version 4. Yes? Okay, and whereas in Git, and it's a little bit different, and it stores something called a snapshot, not the difference between the versions. Okay, so once you, once you had a new version, it will store that version completely, but not just the difference between this version and previous one. Okay, so I have to quit, rerun the cell. Okay, and so if you look at this file, this picture below, and it explains how this works. So let's say in the version 1, we start with 3 files, file A, B, and C, and then something changed in the project. So now only changes, file A and C got changed. So now you have version A1 and C1 now, because these are the new files versions. And whereas B doesn't change, so in this case, it does not store a new version of B because nothing changed, just stores a reference to the original copy. And then say in version 3, the changes is only to C, and so then you have a new version of the C file C, which is called C2 now, but A1 and B will just a reference. So A1 will have a reference to a previous version, which is here, and say the B will have reference to original version, still B, and this goes on. Okay, and so all these changes you can be stored locally because they have a local copy of the database. And also, and this may be not an okay. This is something maybe interesting to know, and is Git use something called a checksum, which is a very long number, like the one at the bottom, this one here, and it is used to check the integrity of the files. Okay, so it is sometimes, for example, if you try to compress some files or transfer some files, you would also get this hash number generated as well. So after you unzip or receive the file, you can check again to see if you get the same number from the file to ensure that it's the correct file, there's no corruption. Okay. And here comes probably the most, hopefully so far, explaining the concept of how Git works. So it's a database, stores different versions of your files, and then more importantly, this database, this version database can be shared among many people and everyone has its own copy. So the next one is about stray states of a file can exist if you're using Git. Okay, and these are called, first called modified. That means there's some changes to the file, and then something called staged. That means the change is being selected to add to the version database. And then finally the committed. Committed just basically means now the change is in the version database. New version is created for the file. Yeah, is that okay? So every changes you make to your code base, any files, would go through these three stages. So first you have to change the file, and then the change needs to be staged. So the Git knows you want to record the change, and then finally that change being committed. That means the change being recorded to the database. Okay, to get the picture back again. Okay. That's better. I have all the pictures back now. Okay, and to make things slightly more complicated, related to the three stages, you have these three different main, they call it sections in the Git, which is the working tree or the working directory, the staging area, which is the middle part, and then the Git directory, And so the working tree or the working directory is your code. So basically that's the directory you put all your files, HTML, CSS, pictures, any other documents. So the staging area is where any files you decided to put onto or move onto this stage, next stage. So okay, so some of the files, when they have the change and you decided to save those changes into the version database, and it goes to the staging area. And finally, when you committed the changes, that means all the changes will be added to the Git repository or the Git directory. So this is where all the changes are saved. Okay, so that's what these three. So essentially, these three sections actually match to the three stages we had in this three states in this slide. Okay, and then so the way in terms actually you work, you would have a directory, and you would want to first tell Git, say, okay, I want to use Git on this directory, and then for anything you change, you move it onto the staging area, and then you do something called commit. The commit is where the part that changes goes to the Git database. Okay, so that's kind of the concept part. Now we have a little bit more hands-on part. So the first thing is you need to install it just as any software. So if you just Google Git, and it should give you where you can download the file. So this is probably the official website. and then you can choose download, and then you can choose different versions, depends on what you're using. Okay, and okay, and so after that, just to check if you have that installed or not, and you should type this line and in your command line. And if you installed, it should output something, and just ignore this part. And that's generated by this Jupyter notebook, which I try to use to create the slides, which try to run this command line as a Python code, which obviously it is not. So that give you this. You can see what this shows IPython. So for example, in my computer, if I type in, let me have a new window, hide this one, can't quite. And are you able to see the text there? Is that big enough? Okay. No. Better? Yeah. Okay, so here, I mean, on Windows it will be slightly different, but it's still a command line interface where you can type in command. So if we just type in git version, okay, so you have to remember you need 2- here. So that's a common thing you will see a lot more later on. Now, when these command line tools add parameters or extra commands, use 2-. Okay, and so it says, okay, give you something. It says git version 2.21. Okay, so that's the version, but at least it tells you it's installed, and you can check whether that's the latest one or not. And have a little bit extra information. Say, okay, this is a Git come out with Apple itself, not something extra I installed. Okay, and basically, if you get some message like this, that means you are fine, or you had it installed, it's working fine. It can find the git command, and it can be able to output the version. And of course, if you don't have git installed, it should tell you some error. Okay, so that's the one I got. And if you don't have it already, the easiest way is just go to the URL here, which is the same as we showed here, and allows you to download. Okay, and once you install the Git, the first thing to do is to configure a few things. Essentially, tell Git about yourself. So what you can do is you can run this command, which is git configure and then list, which just shows existing and configuration or settings of Git. So these are fairly basic things. For example, it knows who you are. So this is information that will use. For example, when you want to add a change to the version database, it needs to know who made the changes. Then it will use your name information and your email address and some other basic simple settings. So I can do this very quickly here. I can say git, okay, configure double list. Okay, and you can see currently the only information or setting about it has is just this one. It says credential.helper equal to OSX keychain. So that means the username passwords will be getting from the keychain maintained. It's like a password database maintained by an operating system. That's all. So it doesn't know, say, name and email it yet. And because I just reinstalled my computer very recently. Okay, and then if you want to add username, you can say, this is an example here, you say configure global user dot name. So I could do git configure global user dot name, and I put my name in there. Okay, nothing really changes. But if we do the list again, you can see, okay, it now knows who is the person using the Git. or whatever name you can put in there. Okay, maybe I should do is okay, that's probably gonna work better. Okay, and then similarly, there's a command we can use to add your email address. Just say user.email, and then there's many other things you can set, which I'm not going to do too much. Okay, and then next we're going to actually creating a Git. So there's a couple of different ways to do, like 2 ways to do this, and you can create your local Git repository first. So I use Git, I run the command, I created my local version database, and then you push it to a remote server. So it's completely fine, so you can have your local Git repository or database and not push it to any remote server. In that sense, you just use that locally by yourself, and if anything happened to your local computer hard drive, then you're going to lose everything, including the versions. And also you will not be able to share with anyone else, which are the 2 issues actually Git was designed to solve. So quite commonly, people would say put it on somewhere else. Okay, and so the second way to do this is I can create a repository in Git using Git first on GitHub, and then I kind of copy that to my local computer. And that way, it will automatically create the connections between your local repository and the one on the server. Okay, and there are many servers to say hosting Git database or repository, and we're going to using GitHub. You can create your own, say, local ones. For example, lots of companies run their own local Git server, so they can share code with their companies. But this is only private, so only people from the company can access the code. So the one we're going to use, it will be called GitHub, and you actually will need to use that for your coursework as well. So all the coursework code needs to go to a GitHub, and have different versions and record all different versions as you progress. So essentially, you need to start using Git once you start working on your coursework, and as you make more changes, you make more commits, essentially creating new versions on the Git database, which is stored on GitHub and your local computer, and that's part of the marking criteria. Okay, and before we have a little bit background about GitHub. It is the largest online host for Git repositories, and so a repository can be a repository of code, but it just could be just a repository of documents or any other files, really. And currently it has more than 100 million, and many of these are open source. So the people who open source, they basically provide the source code for whatever they are creating, and they use GitHub, and because it's besides hosting or saving the code and its versions, and it allows you to do other things. For example, for tracking issues, say if it is a bug, you can create an issue and you can use that to document the changes of the bug. You can use that for code reviews. People can check your code and to see if there are any problems or the quality issues you can have. And finally, for collaboration. So most of these projects, you have much more than 1 people working on it, and the way for these people to working on the same software or same code base is through Git or some other similar version control system. Okay, and so there I listed some of these maybe more famous examples, which are hosted on GitHub. Basically, everyone can see their code and potentially contribute. And so the first one is Visual Studio Code, which is the one we use for this module. Itself is open source, or its source code is on GitHub. Everyone can see and actually contribute. Say, for example, If you don't like how Visual Studio Code works, you can make changes and create something called a pull request. And if the people who manage Visual Studio Code likes your changes, and then they can include that into the main branch called the code, and then that may come into, say, becomes everyone would use that in the next version of the Visual Studio Code. And also in this module, we talk about different JavaScript frameworks. We mentioned the React, Angular, and Vue. Again, all these are open source projects. They are all hosted on GitHub. And anyone knows what TensorFlow is? Okay. So if you're taking the AI module, it may get mentioned. So TensorFlow is like the latest breakthrough in the machine learning or artificial intelligence field. As a particular tools allow to do some amazing things. So most famous one will be, and recently there's this computer program which can beat the best human Go player. Anyone heard of that? Not really. Okay. So does anyone know what the game of Go is?
Yeah.
Not many. So you all know chess, right? Everyone knows chess, yeah? And so you all know, say, IBM had this computer called Deep Blue, which beat the world champion in chess. Anyone knows roughly when? So at least 20 years ago now. And at that time, people predicted the Go is not be beaten by any computer program for, say, another century or something. Partly because Go itself is way more complicated than a chess. So basically, that's what the Go looks like. The rule is very simple. You have two sides. One side use the white one, the other one is black one. They try to control as many space on the board as possible. That's all it does. So, for example, the white one would say, more or less to say this part belongs to the white, and maybe say this part belongs to the black. And then in the end, the part with more space wins. The rules is very simple, but the game itself is much more complicated than chess. And some famous computer scientists predict it will take 100 years before the computer can beat best human players. Okay, and very recently, where's the lecture slides? And there's this TensorFlow came along, made by a company which is bought by Google. They come up with this algorithm beats the best human players very quickly. Okay, but anyway, so that's again is on the GitHub as one of the open repositories. Okay, and so the Git was really designed for a team to work on any software project, because any software is you need more than one people to do. Like any of the serious ones, you can't just done by one person. It might take a single person more than 100 years to do it, which is definitely not practical. And for this module, we're gonna mostly just use that for personal purpose. So you at least need to use that for your coursework. So keep versions of your different versions of your coursework. You might want to use it, for example, when you have a group task. For example, you need to complete in the lab. You can put the code on a GitHub repository so everyone in the group can contribute and work on the same code base together. Okay, let me see in terms of how I'm doing in terms of time. So obviously, if you're going to use GitHub, you have to create an account first. So that's what the page will look like. So I assume many of you haven't had an account yet, but it's very simple. So all you need to do is pick a username, enter your email address, and then a password, and that's all it is. Okay, maybe I just show very quickly what it's gonna look like. So if you go to GitHub, so the URL is called github.com. Obviously, it's quite small here. You can't really see. Okay, so this is what it looks like if you don't have account or not logged in yet. So you need to pick up a username. Why I can't change that one? Okay. You need to enter your username, email address, and pick a password. And if it's a username already being used, then you can't use it. But that's all it is, really. So then you just can create an account. Okay, if you already have one, you sign in, and it goes to something like this. And yours will be a bit different, because this one, I already had lots of projects and repositories. So it will show up here to showing, maybe very quickly, this left-hand side shows you different repositories I'm working on, and this part shows what are things happening in this different repository I'm involved. And this part recommend you some other things you might be interested in from the GitHub. Okay, and back to the slides itself. And so for you, I'm going to do that in the lab next week. So the first thing you probably want to do is create a new Git repository. And once you had account, you can do this very easily. So this part, essentially, if I go to this page and I click the plus button, and then I choose a new repository, and that's the interface you will see, which is the same as the slides. And you need to pick a name for your new repository, and there's certain rules, and you have to follow them. Let's say this is my project, and you can have some text description. It says it's optional. But just typing something. The demonstration for how to use Git. Okay, this part is quite important. So you need to decide whether your repository is going to be public or private. And so previously, you have to pay money. If you use a free account with GitHub, all your repository will be forced into public. Now that changed recently, so now you can have private repositories. So the name is quite self-explanatory in the sense, if it's public, then everything in your repository other people would be able to see. Doesn't mean they can change, but means they can see. So for example, if you put your code in your repository, other people can see the files, and they can download the files and open them. And then if it's private, that just basically means only people have access to the repository can see it. So you would have access to it because you are the person who created the repository, but you can also give access to other people, for example, and other members in your team, access to the repository so they can see it as well. And so I would recommend create private to start with, and then later on you can actually change in the settings. If you want to make your private repository public, you can always do that later on. You can also do the other way around. You can make a public one private. But by that time, people might already download your code, so it may not entirely private. Okay, so the next part is about initializing the repository with a document called README. So I would suggest ticking this box, enable this option, and just purely for the reasons say here. So this would allow you to clone the project, essentially copy this repository onto your computer immediately. So if you don't have this README, you will not be able to. So let's say I'm gonna create this repository. Okay. And so this is what it looked like on the page once you had a new repository. That's your title. This is your list of files. Currently, there's only one file. The README said I want to create automatically. And also here, would show the content of the readme.md. So you can edit the file, it will show up here. And here in the readme itself, it just created the title and description I typed in when I created the project. That's all. Okay, back to the slides. Okay, so far, this Git repository only exists on the GitHub website. You don't have it on your local computer yet. So what you want to do, because is to clone or copy that repository onto your computer, because every change you made, it has to be on your computer. It's not very easy, even to say, and if you're creating your app, you write JavaScript code, do all the code editing online in github.com. So most of the changes need to be done locally. So this is where you need to use the clone. So there's a button there. Is anything more below? Okay. Okay, and you click that green button, which is called clone, and you need to copy this URL, which is like the URL for your GitHub repository. That is needed when you try to create a local copy of that. Okay, maybe just do that now. So I'll click this button. It will say clone or download. And then you would have this URL here. And all you need to do is click this copy button. And it will say, okay, now it's copied, saved in the clipboard. And you do have other options. For example, you can open in desktop. And that basically means open in a client software made by GitHub. So GitHub made some software allows you to use on your own computer, or download everything as a zip, and which I not recommend, because if you do that, it will not include the connections between your local copy and the server and the repository created on the GitHub. Okay, once you do this, next you need to do, is to clone locally. So this is what you need to type. You need to type git clone your repository URL. So basically, that's the part which you just copied from here, which is this. Okay, let me see. Yeah, that's what it looks like. And the things you need to be aware is you do that in a command line and make sure put it where you wanted the files to be stored. For example, you have a directory on your computer where you store all your code. Then do this command line, git clone, in that particular directory. So it will automatically create a folder in that directory which links to the remote repository. So I'm going to do that now. For example, on my computer, currently I'm at, okay, it just says I'm currently at user/my name. So I probably don't just want to put my code or repository there. I can have a look. I don't really have anyone. So maybe let's say I make a repository directory called code. Okay, so now I have a directory called code now, so I can go into that directory. Oops. There's nothing there. And I can type the command. And so it says git clone, and then followed by the URL, which you copied from the web page here. Yeah, and then you enter. Okay. So it will try to say clone into GitHub. Sorry, clone into Git demo, which is the name of the project or repository. And then because we picked as a private repository, so you have to enter your username password before it will allow you to get the code. So I have to type in my, I think, if I remember. Okay, so it allows me to do that. And if we give you a little bit extra information, so I say there's 3 items in the entire repository. Okay, and then actually, and the Git is a little bit smart. It will also always do a compression. So try to compress the files before it transfer. and then download. When it's finished, it's okay, it's all done. And so what you can see here now is if I do a list, I have this is actually a directory called Git demo, which is the name of the project. And I can say list Git demo. And you can see inside that directory, we have only one file, which is the README, which is one you have. It's not particularly exciting. And then the content of that is just line of text as shown in the here. Okay, yeah, so I had a slightly different project there. So that project was called Learn Git, and I had a different one, but you should have that local copy now. Okay, so, wow. So what we have done so far, we created an account on GitHub, which you need to, and then on the GitHub, you need to create a repository. You have to give it a name. Learn Git or Git demo in this case, and then you clone that repository onto your local computer where you're actually adding or editing files. Okay, so this is probably the most important, the last line. So after you've done the clone, so the Git software understands your local directory, Learn Git or Git demo, is connected to the Git repository on the github.com. That's the most important part. Otherwise, the two are not connected, and without that connection, it will not be able to know how to save your local changes to the server. Okay. And if you remember these three sections, I think it's called sections, and now you already have your working directory on your computer, which is the directory you created, which is the git-demo or some other names. Okay, and we haven't made any changes to our code yet. We have no new files or no change to the README itself, so there's nothing to stage. And this is already also created the .git directory. So by default, it's hidden. So in this case, if I go here, if I do just a list, and you only see README file, but if you list all the files, you can see there's a file called .git there. Okay, this is where all the Git database stays, and you very, very rarely need to actually access any files there. And it's all managed by the Git. You shouldn't actually change, because in most cases, they only just mess things up. Okay, and this is so this is actually tells you what's inside .git. So there's quite a few other things in there and under the directory as well. Just leave them there and just know it exists will be enough. Okay, so that's next thing you need to understand. So for all the files inside your working directory, in this case Git demo, they have two status. One is called tracked, one is called untracked. So untracked means Git doesn't care about these files if they are changed, and Git would not know or interested in. So they're only interested in the so-called tracked files, which says if anything changed, the change will be recorded in the version database. So in that sense, if you have a directory, you have lots of files, some of the things you don't want Git to keep tracking their changes, then you can set their status as untracked, and only make those you want to keep tracking as they track the states. So obviously you probably want to all your code, for example HTML, CSS, as tracked status, so it can record all the changes. Okay, in in our example so far, we only have one file, which is called readme, and that is we get it from the GitHub, so it's in the tracked status by default. And any files that you later on created in the directory, it will be in the untracked status initially. So any new files you copy or created in the directory, it will be untracked status. Then you have to tell Git, say, okay, these are the files I want to track. Okay, and then this is a slightly more complicated diagrams showing about different stages of the file. As we said, any new files added and will be untracked first, and you can tell the Git say you want to track these files, and it becomes tracked, but also at that stage still unmodified because you haven't made any changes yet. And after that, after you make changes, it becomes modified, and finally, you want to say I want to adding these changes, the modification made in this like yellow state to the GitHub repository, and you have to make these files called staged. Okay. Okay, and so this is one of the ones you're probably going to use the most, is called Git status, and which is tools tell you what files in your working tree and which status these files are. Okay, so to run this, it has to be inside a Git repository directory. So for example, and for example, if I just run here, run git status, and it will give you an error message, say because this is not a GitHub repository, so it can't run git status. So I have to okay, if I run inside the directory, which I just cloned, and it will tell you some information like this. It says on branch master, we'll explain what branch means later. And it says your branch is up to date with origin/master. So the origin master refers to the repository on the github.com. So it will tell you if there are any changes or difference between your local version and the version on the central database. So when it says you're up to date, that means these two copies are exactly the same. It's okay. And when there is a difference and it becomes an issue, you have to make sure they are the same. Okay, finally, this line says nothing to commit, working tree clean. So that means it did not see any changes in your local copy. And there's no changes to add to the version database. That's all it says so far. And when you're starting adding new files and make them track the status, you will see more messages here. Okay, so this is what we're seeing in our example. Okay, hopefully I had that. Okay, now let's say I'm starting working on my project now or for my coursework, and I want to create my files now. The first file I'm going to create is called index.html. And let's say we're going to start it here. Start my favorite tools called Visual Studio Code. And then let's create a new file. I'll save it in the directory and called index.html. And then I put in something inside my file, which is really nothing yet. Okay, so I had an empty HTML file, but at least it has some code in it. The file is called HTML index.html. And then I'll go back to the same directory if I do a list. you can see there are now two files. So besides readme, I have index.html as well. But the same thing is if I run now git status, and it will detect, okay, so now I have a untracked files. That's the new file. It not exist in this working directory before. It detected, and it actually tells you, say, if you want to track the files, and you should use this command, and then the Git will try to save any changes to that files to the database. So that's probably what we want to do. Okay, as we said, if you want to Git to track something, and you use add. Okay, so we can do, and then it will tell you something is a bit changed. So just go back here, and if I say git add index.html, that means I want to get to tracking this particular file, and this is no return, no feedback. That means everything is okay. If I run git status again, it will now saying, okay, changes to be committed. So there's a new file called this. And it tells you, okay, if you don't want to include this change, you should use git reset, which is something we're going to cover later on. Let me see. And okay, and just very briefly, so we had index.html created in directory. It would start with an untracked status, and then we used git add, and that becomes a tracked file, and it goes straight to modify states, skipping this one because that's a new file, doesn't exist before. And then next one is also staged as well, and then we can just commit after that. Okay. Okay. So before we making a commit, and we can also see if we change the files and we don't the so-called stage it, then the changes in that files will not be added to the things to be committed. Okay. I know this is maybe a little bit long-winded statement, but again, go back to this our very simple example. We have two files. The readme.md is something that comes from the repository itself. This is a change. Okay, so we can make changes to the readme file. We add a new line, and then if we go back here, if you run git status, maybe I do. Okay. So you can see there is one file that's ready to be committed. There's another file which is tracking, so it knows it's modified, but this change is not staged, so that will be not included in the commit. So basically, if you now add things to the Git, want to add all the changes to the Git database, which creates a new version, only this change will be included, but not this one. Okay, so let's say we want to include this one in our next new version as well. So this is what you need to do. Again, you just use add. Then that we're including the changes. So included the changes in, so move that to the staged status. So we just do git add readme. Okay, and then if we do the status again, you can see, okay, now it has two changes that needs to be added to the version database when you commit again. So there's a modified readme file and the index.html file we just created. Okay, so the commit is where you're adding all the changes to the Git database. So the actual database, you don't need to worry too much about. You just say, okay, this is okay, I'm happy with these changes, and I want to create a new version with this. And all you need to do is just do git commit, that's all. And in most of the cases, it will pop up an editor to ask you to type in some messages. So it allows, it forces you to write something about what this new version is. So for example, I can write a message, say, this is the version with, I added index.html file, and I updated the readme. So later on, when you look at the version, instead of just number, you have more meaningful descriptions of what you did in this new version. Okay, so when you install Git on your computer, it will ask you to say what text editor you want to use to enter in these messages for each new version. Okay, and if you didn't pick one, and it will, for example, on Mac, it will force you to use VI, which is not the most user-friendly text editor. So just be careful. And this is also something you can change in the Git settings to say which editor you should use. Okay, and alternatively, what you can do is you can add the message itself in your git commit command. So that's what I'm going to do now. So I don't want to use, say, any editor. I just want to type in my message. Okay, in our case, I'm going to do, so git commit M stands for message, and then I type in the actual message I want to do. Created index.html and updated readme. Okay, so if you enter, okay, and so this is a little bit extra information. After you first set up your information about your name and email address, but more importantly is this one. It says 2 files changed, 15 insertions, 1 deletions. These are changes in your code. And then this is, okay, you don't have to worry too much about this. That's the mode for this one. Okay, and what you can know is now if you run git status again, it will show like this. Your branch is ahead of original master by 1 commit. And you can use git push to publish your local commits. Okay, so what's happening now is because you updated your local Git database with a new version, you have new files and changed 2 files. But the remote one, which stays on the github.com, don't have these changes yet. They still have the original state when you create your first repository. Okay. So it tells you can use git push actually to send these changes to the version database on the github.com, so they will update as well. Okay. Okay, and also there's this part here. It says nothing to commit, working tree clean. That means since you made a commit, there's no more changes to the local code, so nothing new to commit. Okay, so what we're going to do is we're going to actually sending these local changes to the remote. Okay, and this is called push. Okay, the particular word or the term it used is called push. And the opposite will call the pull. That's where you're getting new changes from the server to your local version. So pull, you're going to use it a lot. And when you're working with a team, people may make changes to the code. And so that means your local version might be outdated. So you want to do a pull at the beginning. Why showing this one? Okay, we are running out of time, so maybe just do these fairly quickly. You can see the details of, say, the remote server where the repository is stored by using the git remote command, which tells you it's stored on origin, which is not particularly informative, not very useful. And then you can specify v, which shows actually a bit more information. So if you do git remote, okay, you can say this is actually the URL where your Git repository exists on the GitHub. So you can see it's github.com, then followed by username, and followed by the repository name, and followed by .git. Okay, now all you need to do is to do the push, so that the changes will be sent from locally to the GitHub server. And so the full command, you have to say git push, and you need to set which remote it is. We're seeing that to be the origin, and we have to set which branch that would be. In our case, it will be master, but in our case, because we can actually just simplify by just typing git and push, and skip the remote and branch, and the git will automatically figure out what would be the best thing to do for those settings. Yeah. So this is what I'm going to do now. So if I type git push, okay, it will give you some information. So it says there's total 6 objects. You finish the counting, and you try to compress all these changes using 4 threads at the same time. The compression ratio is very high, and you send these files over through the network. That's the speed. And finally say, okay, it's all done. Okay, so if you get a message like this, that means it's done successfully. And if we go back to here, and we go back to the page on the GitHub, so this is the original state when we created. And if we refresh the browser, the page now, okay, you should see, okay, now you have a index.html, which we just created locally and pushed to the server. And you should see here, it says 2 commits. And that's the initial one when I create a repository. And this is the second one when I push the changes from my local computer. Yeah?
Do the commits show up even if you don't push it?
No, if you don't push your commit, it will stay on your local computer. The server will know you made changes. And the message here is what the message you typed in when you make the commit. Oops, I have to go back here. Yeah, and it's also give you information such as who made the commits, because in some cases it might be more than one person. Ah, it doesn't recognize it's me. Okay. Okay, as I mentioned before, the opposite of the push is the pull, and that means when the files on the server is ahead of what your local change is. So maybe other people contributed to the repository, there's new files and new changes, which you don't have on your local copy yet, then you're going to have to use pull. And the command is quite simple. It just say git pull, and we'll try to get the changes. Okay, and this is more just like a recommendation, is to commit often. So don't wait until you finish your everything, it's ready to be submitted, and then do a commit. Every time you think you spend an hour or so on your code already, make a commit. Or you say you complete one of the features. For example, you created the forms for login. For example, you had a title and some text field and button. Commit. Especially when it's working fine, commit. So that you know you have something there which is definitely working. And later on, if everything else breaks the code, you can always go back easily. I think there was a requirement for the first coursework. You need to have at least 10 commits. But you can easily have more, 100 or more commits on relatively large projects. Okay, we are almost there. And the last thing I want to show you is actually you can use Visual Studio Code either as a command line for Git or use the built-in tools like the interface without typing the code. So if we go to GitHub and let's say we make more changes. Okay, so the first thing is you can open the terminal window. And so if you go to view and go terminal, and it will show a terminal little window here. Okay, this is the same as this one. And the main difference is if you use this one, it will always be in the directory where the code is. So you don't have to move your, say, change directory path. And you can just type as you want, as you choose, and you get the same output and everything. So you can type all the, say, the push, pull, commit, command, or add here. Okay, and also the Git has a built-in kind of menu for Git, which is the third button on the right. And if you click, you can see currently it has 1. That means it detects 1 changes. And you can say, you actually can tell you README has been changed. And it can actually type in a message here. And it says if you do, this is on Mac, say Command Enter, it will actually commit for you. So instead of typing in the browser, it's to say git commit message, more changes, something, something. You can do it here as well. And there's quite a few other functions you can do. You can do pull or push here as well. Okay, I think that's all. So in terms of reading, that's the link there. So that's the book called Pro Git. And today we covered the first and second chapters. Okay, that's all we're gonna need to know for the Git, using Git for this module. Okay, that's it.